So this is a video I'm doing for my dad. He has a problem that he's trying to figure out for a test at for work, and it's a trig problem. He was given 20 degrees for theta. Theta is just a way to represent an unknown angle in any triangle or many other things that you're dealing with in math. It's just you use some Greek letters because people are used to it that way. It's a way of notation, basically. So he was given 20 degrees. The length of side A, which is 6, and you got B and C here. A, B, and C. All these are always direct opposites of each other when you're labeling the triangle. So you got a little a is opposite of big A, little b is opposite of big B, little c is opposite of big C, and this is a general accepted way of labeling a triangle. C is usually the hypotenuse. So if you're going to use pythag, like we're going to use pythag later, C is going to be the hypotenuse in that equation there. We're gonna solve for a different variable, but we need to know what C is. C is the hypotenuse. So that's the general accepted way of understanding that. There are trigonometric identities, functions that you can use for solving problems like this. And there's a little saying. It's called so katoa. And this is a way to find out the length of a side of a triangle with a given angle and one of the other sides that are given. So he was given 20 degrees, and obviously it's a right triangle, so we know that that's 90, and 90 plus 20 is 110, 180 minus 110 is 70, so we know that 70 is the length, or the degree of B. My oven is done, so I will finish it. I will hold it and finish it. This is going to be difficult. Talking and doing this at the same time, this is weird. So anyway, SOHCAHTOA is the saying that we use in trig, which means sine equals opposite over hypotenuse. And here comes my girlfriend, so she's going to hold the phone again. Thank you for shutting off the oven. Theta is represented as 20 degrees here. 20 degrees, we're going to put in theta's place, so sine of 20 is equal to the opposite over hypotenuse. Sine, cosine, tangent, they're all just ratios of the sides that you're setting it equal to. So the ratio of cosine is adjacent over hypotenuse. The ratio of tangent is opposite over adjacent. The ratio of sine is opposite over hypotenuse. Those, when you divide these numbers, it's equal to the sine of that degree. Like, this is an actual number. When you punch it in a calculator, you get an actual number. You take this divided by this once we find it, once we solve for it. So 6 divided by 17.54 is going to be equal to sine of 20. It's just a ratio. That's the easiest way to understand it and when you're first starting out. So we have sine of theta, which is 20 degrees, is equal to the opposite over the hypotenuse. 6 is the given side that they gave us in the problem, which is the opposite of theta, which is A. So just notice that big A, little a. Okay? Just notice that. Because sine is the opposite over the hypotenuse. So you got a 6 in the hypotenuse, which is something we don't know right now, which is C. We don't know C. C is always the hypotenuse. It doesn't have to be, but when you're starting out, it always is. They switch stuff up on you later. But anyway, so 6 divided by y, which is C. And a way to manipulate this algebraically in order to isolate y, because that's the first side that we're trying to solve for, is 6 divided by y, because the opposite over hypotenuse, we didn't change anything here, is equal to sine of 20 over 1. always things are divided by 1. Like, you don't have to write it there. I'm just writing it there because some people might like not understand when I go to the next step why it's 1 over sine of 20. Because it was sine of 20 over 1. So we want to isolate y. In order to get y on top, to isolate it, you can just flip these around. Both sides. Whatever you do to one side of the equation, you got to do to the other. So 6 divided by y, sine 20 divided by 1. So you take the y, you put it on top, and you 6 on the bottom. Sine, you put it on the bottom, you take the 1, you put it on top. So it's y over 6 equals 1 over sine 20. Now, to isolate y, just multiply by 6. Multiply by 6. 6's cancel. You're left just with y. 6 times 1 is 6. And you're left with sine of 20 on the bottom, right here. And you didn't do anything to the denominator, just the numerator. You punch this in your calculator. You'll find the sine function literally written as sine on your calculator. And you gotta, tell what degree to put in. So the calculator knows what the number is as a value. So 6 divided by this is this. And we have solved for c now. Now, we have a, little c, big C, big B, but we don't know what little b is. We don't know what that guy is. So there's another equation that is commonly used. It's a squared plus b squared equals c squared. And you can isolate b in this equation here to solve for it, right there. So basically what happens is you got c squared equals a squared plus b squared. You take an a away from both sides, and you get b squared equals square root of c squared minus a squared. So you took the a squared over here, so minus a squared, and then you square root it, and you square root the b, and when you square root the b, it gets rid of the squared part here. The squared is like the opposite of the square root, so they just kind of cancel each other out. So you're just left with b. So b equals c squared minus a squared. The c that we found out originally from doing the sine function, the SOHCAHTOA, so is opposite over hypotenuse, is 17.54. So that's c in the problem here. So 17.54 squared minus 6 squared. Well, a was given to us already, and a is 6. So we say 17.54 squared minus 6 squared. The square root of all of that gives us 16.48. And basically, that's it. I mean, this kind of proves it common sense-wise because the hypotenuse is always the longest side of the triangle. And 17.54 is bigger than 16.48, which is also bigger than 6. So that's a way to use the sine. You would use the cosine or the tangent like the same way. You would set it up the same way. It's cosine of the angle equals adjacent over hypotenuse. And the tangent of the angle is equal to the opposite over the adjacent. And you just have to use your algebra and solve for whatever you're looking for in the problem. So, thanks for watching.